Okay, my name is Mikhailo. I'm working in Luxoft more than 8 years as test engineer and about 2.5 years as automation QA engineer. Today we will talk about design patterns in QA automation, how to use them, how to write a good framework. We will use examples with Selenium WebDriver library and TestNG and Java language. So the content of our seminar is the following. Firstly, we will talk a little about test automation in general, its benefits. Then we will talk about design patterns. We will cover the following design patterns. It's four-phase test, page object pattern, page factory pattern. Those three patterns are mostly used in QA automation. Other patterns such as Singleton, builder, factory, and abstract factory are used mostly in developing, so the purpose of using them is the same in QA automation, test automation, and while developing applications. So, what is test automation? It's when we when we use automation tools to write and execute test cases, so no manual involvement is required while executing them. So we take simply our test cases for manual execution and automate them using any automation tool and programming language. As I said before, we will see examples how to automate application with Selenium WebDriver and Java language. The benefits of test automation. Firstly, it's saving time. So we can run our automation tests in any minute after every release at night. So for example, when we have very big suite for regression testing and it can take like 1 week for 5 test engineers, and in opposite hand we can have automation tests that cover all regression test suite. So we can just simply run this test suite at night and we'll have a lot of benefits like save time. The second point is fast execution. It's connected with saving time because we can run our tests in every moment, and after they are executed, see the results, and we can realize the current status of our application. Is it stable? Does it have any issues, problems, and so on? Repeatability and accuracy. So we can, when we run our automation tests, we eliminate a kind of human errors. For example, test engineer, when he's executing test case manually, he can make a like human mistake, forgot to execute any step of the case, and so on. And in the result, he will miss and doesn't find any bugs. But automation tests, if they are written correctly, they are very good, so they eliminate the human errors. And the accuracy of the automation tests is also the plus, because when we write automation tests, we set up test data which is be used in our test, and we make source verification in the end of our tests. So every time our test is run, it will accurate and we will see the result. Maintenance of the test suite. Very often when manual test engineers have a lot of test cases, they can be outdated. So for example, application is changing, new acceptance criteria is coming, and sometimes manual QA engineer can forget to update the manual test cases. But in case of test automation, when application was changed, after our tests are run, we can see that our automation test will be failed red, and we can see and correct our automation test, so it will be always updated. And our automation tests are reusable, so we can run them in every moment, as I said. So big suits like regression suits we can run at night. So, but that was the advantages of test automation, but test automation also have some disadvantages because it requires a lot of time to write automation tests, to support the maintenance. After every change in the application, we need to correct our tests, so it requires a lot of time. And when we do not have time for doing this, so we will have troubles. So our automation test also can be outdated, and we will not have any benefits of it. Design patterns. In software engineering, a design pattern is a general reusable solution to a common occurring problem. So, for example, when we have any problem, it can be already solved by any pattern. But I want to say that design pattern is not finished solution, so it cannot be transformed directly into the code. We need to adapt it, test it after the implementation of the pattern, and after the testing, we need to maybe measure performance of running our tests. So sometimes it can be better without patterns than with them, so we need to use them carefully. The first pattern we will talk about is four-phase test. It's pattern in general how to write test methods. The goal of this pattern is to create concise, readable, and well-structured tests. We design each test to have four distinct phases that are executed in sequence. That four phases are set up. It establishes the precondition to the test. For example, if we write test using Selenium WebDriver, in setup phase we can instantiate instance of our WebDriver, make set up any preference for our driver. We can execute also in setup phase, maybe opening the application, so and so on. It's some preconditions that we can do before test method. Exercise the test simulate the system under test. Logic that is to be tested. So exercise phase, it's phase when we do our step actions, manipulating our browser. It's we follow our actions of our test case. Verify phase, it's phase when we check that expected outcome has actually occurred. So it's the phase when we make verification assertions, so to check that our test method then after execution particular steps, our application behaves as we expected. And the last phase is cleanup. It's returning our system application to its initial state after the test. So, for example, we can clear browser cache after the test method executed, or just create our WebDriver if it's needed, and so on. The structural diagram of four-phase tests is the following. In the right, we have test runner of our test methods. It can be in Java testng or GenUnit. This block is test case class which contains test methods, and we can see that each test method consists of setup phase, exercise phase, verify phase, and tear down phase. Actually, setup and tear down phases, as you can see, they cannot interact with our system under test. So in setup phase and tear down, we can make interactions without our application. It's like preparation for our test. Exercise phase and verify phase, they manipulate with our application. So using Selenium WebDriver, we can make actions with our applications, so with elements. And in verify phase, we also make assertion verification that our test case is passed, so our functionality is working. Implementation notes of this pattern, so we can, in the simplest case, each test method can consist of all these four phases. So it's freestanding. It does all four phases of the test within the body of the test method. So all these phases are in test method. The other choice is to take advantage of the test automation framework support for implicit setup and implicit tear down. So for example, in all our tests, we need to instantiate our WebDriver, so we can do it in base test class that is parent for all test classes. So in before method of testng library, we can create our WebDriver, make driver get URL, and the same for after method. So we can make implicit tear down. So in this case, our test methods will consist only with verification phase and execution phases. And setup and tear down phases will be located in some base class for all our test classes. The next pattern is page objects. So very often when manual QA engineer want to become a automation tester, he learn WebDriver as a testing tool, any programming language that is supported by testing tool. For example, WebDriver supports Java, C#, JavaScript, Python, and so on. And after that, he need to learn WebDriver library, and then he can start writing tests. So the simple test without using of object pattern will be the following. Let's assume that we have a WebDriver instance, and our test method will test like successful login for any application. So we test that we can successfully log in. Firstly, we can enter username and password for our login form, and then click login button. And after that, we need to verify that we are logged in. So in my example, we just verify that element by ID upload box is existed. So it means that we are logged in my test method. But we have disadvantages of such writing tests, because all web element selectors can and will be duplicated in a lot of methods, so we will have a lot of code duplication, and after even small change in application we need to change selectors and the logic how it's implemented in a lot of places, so we will have a lot of duplicates, difficult to maintain such tests. It's not very good to write tests as in this example. So what we can do, we can use page object pattern. Page object pattern, it's design pattern which has become popular in test automation for reducing code duplication and increasing test maintenance. A page object is an object-oriented class that contains the representation of the page. So this class will have a description of all elements of the page and the logic of the page. Tests then use the methods of this page object class whenever they need to interact with the UI of the particular page. So using page object pattern, we will split code of test methods with actions and verifications and description of the page. So when in test methods, we will just use the methods of the particular page object class. General rules of writing of implementing page object pattern. Try to not expose the internals of the page. So the internals, like small interaction with elements, like clicking on one element, it should not be exposed. It should be private, or it should make public only big blocks. For example, for login test, we can make just one login method with in login page class, which will take as parameters string username and string password, two parameters, and this method in login page class will do the login. Page objects themselves should never make verification and assertion. This is a part of our test and should be always in the test code, never in a page object. Actually, it is a description as it was designed by Selenium developers. But in practice, sometimes we need to make verification in page objects, so it can be. Method should return other page objects. It's actually as it's used in the classic page object. So all methods in the page object classes should return other methods or themselves or itself. So for example, login method, as we expected that we will login, should return home page class. A page object class does not necessarily need to represent an entire page. If a page has multiple big components, it may improve maintainability if there is a separate page object for each component. So we can extract some components on this page to different page object classes. But on the main page, we may make methods that will return our block components that are extracted. Different results for the same actions are modeled as different methods. So for example, if we have a login method and we suppose that we should log in, so we do not test login in this method, we will test, for example, home page. On the other hand, we will have test methods that need to test login itself. So in testing login itself, we do not know if we will log in or not. So in this case, such method should return the parent of all pages, for example, page object class, not exactly login page or home page. And when we suppose that we should definitely login, in this case, login method should return home page. Applying the page object techniques, our example could be rewritten. So we will have login page class with method login with valid credentials or just login method. This method supposes that we will log in successfully. This method takes two parameters, username and password, and please pay attention that it returns home page because in this method we will successfully log in. In this method we just fill username and password fields and click login button to return new home page. We will have one more page object for our simple test. It's home page class. It will have, in our case, only one method for verifying that we are logged in. For example, I am checking that element upload box is present. So it will return true if we log it in and return false if we will not found upload box. So in this case we will not log in. And test itself using page object pattern will be the following. So we create instance of login page, then we invoke our login with valid credentials method, that and that method should return us home page. And we make the assertion that our check-in upload box element is present. So it's writing such tests is simpler, and we can reuse methods from the login page class and home page class written already in all our tested when it's needed. The class diagram actually it's class diagram for it's not suited for all web application, but for some of them it will be good. So for example, we have page object class. It's parent for all our page object components. We have login page that will be that extends page objects. So that's all are childs of page objects. So login page, then we have page base page. From base page, all our concrete page will be extended. So base page will have childs all our concrete page. Then we can have some footer block, top menu block, and that blocks will be extended from page object. And our tests just use methods, public methods from our page object components. Benefits of using page object pattern. It increasing test maintenance and reducing code duplication, as I said before. Then, if any UI change for the page are required, the tests themselves don't need to change. We only need to change the code in our page object classes. Using page object pattern, it's easy to support and extend our classes because all our URL elements, selectors, related to the page are located in one place. Page factory pattern, this pattern is used with page object to make using it easier. WebDriver provides us a way to map page object class to a real web page by using page object pattern. And by using page factory, we can initialize and mapping the page object fields in our page object class. So the following method will attempt to instantiate our login page class. when we do page factory init elements, it when we do page factory init elements, we will proxy initialize all fields in our login page class, and this factory method will return us instance of our login page. The parameters should be driver for finding elements in our login page class and the particular class itself. In our case, it's login page class. When we do page factory init elements, then we set lazy proxy for each of the web element and list web elements fields that we have declared in our login page class, assuming that the field name is also the HTML element's ID or name. This means that for login page class, there will be an element that can be located using the express expression with ID txt-login or name txt-login. So in our example, in login page class, we have private field txt-login of type web element. This means that WebDriver will proxy initialize our elements and do find element uh, when we will invoke any methods from this element. So we do not require to make like driver find element by particular selector. WebDriver in this case will do this work instead of us. So in our test methods we can do just txt-login send keys, and in this case WebDriver find web element lazy for us. Also, please note that we need to invoke page factory init elements and pass driver and the login page class. If we will not do it and invoke sendKeys method from our txt-login field in any test method, we will have a null pointer exception because our txt-login field is not initialized. By default, the element of the list of elements is looked up each and every time a method is called upon it. So when we call method from the txt password in this example, every time WebDriver will find this element. So for every call. But if we want to change the behavior, so the field, the found field could be cached. So we just can use cache lookup annotation as for txt-login field. But use it carefully because when we first time make an interaction with this element, for example, txt-login send keys, after that we can refresh page, and if we won't make any interaction with this element, we will receive stale element reference exception because page was refreshed and our element was cached. So page factory does not make finding it again. To change how the element is located, use the find by annotation. So as you can see, for login button field, we can find it not only by name or ID. In this case, it's ID, but we can use all selectors supported by WebDriver is CSS, class name, XPaths, tag name, link text. So you can use find by annotation. For me, it's better to use find by annotation always. Notes: if you don't use page factory init elements, so then we will have null pointer exception that in case you will want to make any interactions with web element, because it's not initialized. So you should always do patch factor init elements. For list web elements, we should use always find by or find by's annotation. Web elements are evaluated lazily. That is, if you never use a web element field in a page object, there will never be a call to find element for it, so it will never be finded. One more note that if you will have a lot of page object components, you can make make page factory init elements in your parent class for all page objects. For example, abstract page object class in my case. So you can execute page factory init elements there and pass as parameters driver and sys. Singleton pattern. So it's a developer's pattern, but in test automation, it's used for the same purposes. So, for example, sometimes we can have kind of classes that we need only one of them. For example, some thread pools, dialog boxes, objects that handle preferences, registry, and so on. In fact, for many of the types of objects, if we were to instantiate more than one, we would run into all some sorts of problems, like incorrect program behavior, overuse of resources, or inconsistent result. In this case, we can use Singleton design pattern, and it resolves all of those concerns. With the Singleton design pattern, we can ensure that it's possible to create only one instance of our class, and we can provide a global point of access to the object. Singleton pattern in QA automation while writing automation tests can be used for working with properties files, which can contain all our credentials, links, and so on. And also it can use from some helpers classes for classes like WebDriver factories that create instance of WebDriver and so on. And here we can see example of WebDriver factory class, which is using classic singleton pattern with lazy initialization. So to make class singleton, you need to have private final static field of type of our singleton class. In our example, it's singleton class. Then we need to make private constructor, so known other classes can create objects of our singleton class. And the last, we need to provide a public global point access to our objects. So in this example, as I said, we use lazy initialization, so get instance method return us instance of our singleton classes. In this method, we just verify if our instance constant is null, so we create new object and then we return is. The second time that we invoke get instance method, so we will not create new singleton object, we just return existed one. It's lazy initialization, but it can have problems in multi-threaded environment. So for multi-threaded environment, the simplest variant of this pattern is the following. So when we make our final static constant field, we assign to it, we create new object of our singleton class and assign to our field. And in getInstance method, we just return already created object. As our instance field is static, so it will be only one instance of our singleton class. And pay attention again that our constructor is private. So it's class diagram. So when client is using, in our case, WebDriver factory or like properties loader class, we every time we interact with the same object because only one instance of WebDriver factory in our case can be created. So we have private static final field instance in our case it's instance name and of type WebDriver factory, private constructor, get instance method that return us WebDriver factory object, and we have here in our case create driver method. It's public or protected. The next pattern is builder. In QA automation, it can be used when we have when we need to write tests for any profile page or sign up page, when we have a lot of fields that are related to account or person. For example, in my here we can see the profile data class that have fields like first name, last name, company name, website, title, phone, and time zone. And when we need to create the object of our data class, so we just can make the constructor public that can accept as parameters values for all our private fields. Actually, in our test, we can pass as parameters just string objects. So we need to pass like 7 strings, but it's more useful to use just profile data object and have extracted class that will contain all our information about profile in our case. So in our case, it's profile data class that contains our fields. And now what if only two fields, first name and last name of our class, are mandatory and other fields are optional? So we need to create an object with two mandatory fields each time, first name, last name, and then we can create an object with different last optional parameters. In this case, we will need more constructors. So it will be constructor for mandatory fields. It will be a constructor if you want also to initialize company fields and so on. We will have a lot of constructors for every optional field. So this pattern is called telescoping constructor, and the good thing that it's working good, but it has problems as you see, and the problems are pretty obvious. When we only have a couple of attributes, it's not a big deal, but as the number of our attribute fields increase, the code becomes harder to read and maintain, and we will have more and more constructors for every optional field. And this code will be harder to use for clients of this class. So this approach, telescoping constructor, have its problems. But we can use Java Beans pattern. In Java Beans convention, for every our field, we can have public setters and getters, and default no arguments constructor. And this approach seems easier to read, maintain, and it is in generally good. So as a client, you can create empty object and then set only attributes that you are interested in. So in our case, for example, we have first name, last name, fields, and others fields. Then we can create just getters, setters for all our fields in our class, and private no arguments constructor is hidden here. So this approach is quite good, but it also has some disadvantages. Sometimes we can have an instance of the class we written with Java being solution in an inconsistent state. So imagine if you want to create a profile data object with some values for its attributes, then the object will not have a complete state until you execute all set x methods, so setters for your fields. This means that some part of the client application might see this object and assume that it's already constructed and ready and can use it. And we will have then the problems. Actually, we will have this approach problems with multi-threading environment. The next problem that we cannot ensure that all necessary setter methods are called, so we cannot ensure it simply. This approach is more complex since one call is replaced with many. So for every field of our class, we need to call its setter. And the profile data class is mutable, which means that it can be changed, and as I said before, we can have problems in multi-threaded environment. But we have one more solution for resolving these problems. It's builder pattern. This pattern uses an additional inner static class, we can call it builder, which help us in building desired profile data or any other object with all mandatory attributes and the combination of optional attributes which are required without using the immutability. So after this object is created using builder pattern, then we could not change the values of its attributes. So the implementation of our profile data class, which is using builder pattern. So we have all our private fields. Then we have private constructor, which accept as parameter the object final of class builder. Builder is static inner class of our profile data class. It has duplication of all our fields attributes of profile data class. Then it should have setters which take as parameters values for our attributes, and we assign parameter of the method to the field in class builder and return this. So every setter method in builder class return itself. And then we should have build method inside builder class that will return us profile data immutable object. And please pay attention that profile data class accept object of type builder. So If our profile class is written using builder pattern, then we can create our object as it's shown in our example. So we just create new profile data, builder, object, and then executor setters. Each setter method return us instance of this builder class, so we can do it in one line. And after all mandatory and optional fields are initialized, we should execute build methods that will return us the fully built object of profile data class. So it has, on my opinion, only one disadvantage, as we should duplicate fields in profile data class and in inner static builder class. So we just need to duplicate the fields, but it's safe in multi-threading environment, and we can create our profile data object in one line in this case. So I would rather use this pattern instead of telescoping constructor on Java Beans. Benefits of builder patterns. The client's code is easy to write and more important to read, so we can just create a profile data object in one line. You are always sure that whenever you get an object of the class written using builder pattern, it will be always in complete state. And profile data class with builder pattern is immutable and safe in multi-threading environment. Factory pattern. Actually, most of us, if already written some automation test, I think use this pattern. It is the most used design pattern in modern programming languages like Java and C Sharp. The purpose of it is that it creates objects without exposing the instantiation logic to the client. So, for example, in WebDriver factory class, we have create driver method that accepts browser string parameters, and it returns WebDriver. As you can see in this method, we check if our parameter equals Chrome, we return new Chrome driver. If it equals Firefox, we return new Firefox driver. So in our case, we return abstract WebDriver class, and the clients of our WebDriver factory API doesn't know which exactly driver is returned. So in all our tests, we use driver, but we do not know which exact one. Because of this, we can write one framework that will be working with all all browsers supported by Selenium WebDriver. And using a factory method is pretty simple. In this example, our WebDriver factory is written using Singleton pattern, so it just invokes get instance methods, and then we invokes create driver method. Create driver method itself use factory pattern, and we send as parameter our browser name. So in our example, we will have driver variable of type driver, and we didn't know which child of WebDriver is returned, concrete instance of WebDriver is returned. We don't know, we just have WebDriver. Implementation nodes. Clients needs a product, but instead of creating it directly using the new operator, they ask the factory for new product, providing the information about the type of object it needs. In our case, we provide as parameter string browser, which could be Chrome, Firefox, AE, and instance of WebDriver will be returned, but we will not know which exact instance it will be. The factory instantiates a new concrete product and then returns to the client the newly created product, casted to abstract product class. In this case, abstract product class is WebDriver class. And the last, the client uses the products as abstract products without being aware about their concrete implementation. As I said before, because of it, we can write framework which will be working with all browsers supported by Selenium WebDriver. The class diagram of factory pattern. Here we can see the client which is asking for a new object, and WebDriver factory create this object and return to the client, but client doesn't know which concrete object is returned. So WebDriver factory create concrete driver but return the abstract WebDriver for the client. Abstract factory pattern. Actually, abstract factory pattern provide an interface for creating families of related dependent objects without specifying their concrete classes. So factory pattern sometimes is called as factory of factories. Abstract factory is a class with several factory methods. So basically, abstract factory class has a collection of different factory methods to create different desired concrete objects. So simply to say, our abstract factory class contains factory methods inside it. Each concrete factory subclass implements the factory methods for a particular family of products. The abstract factory pattern can be considered as an extension for the factory method pattern, because the abstract factory pattern contains factory method pattern in it. When it can be used in QA automation. Actually, in my experience, I use this pattern. For example, when we had our application, and some customers that bought our application would want particular functionality, but they wanted this functionality to work slightly different. So in this case, the internal functionality in general is the same, but with some different details inside it. And in this case, we cannot write like one method for working with for different brandings in page object class. We need to use abstract factory for it. Let's assume that we have a profile page with same functionality, but it works differently for various branding. So in this case, abstract branding factory for our profile page will consist of one abstract class, abstract branding factory, and two concrete factory classes for every branding. So in our example, we have abstract branding factory class, which return, and this class contains of profile page method that return as abstract profile page So this profile page method is factory method, and we have a concrete realization of our branding factory. It's red branding factory, for example, and green branding factory, which extend in abstract branding factory class, and they implement profile page method. Pay attention that the profile page method return as abstract profile page, as in case of factory pattern when we return from create driver method, we return abstract WebDriver. So in this case, we return abstract profile. The return type is abstract profile page, but we return the particular realization of our page. In this case, we return concrete red profile page. For green branding factory, implementation is the same, but profile implemented profile page method return us the new green profile page object. So how we can use it while writing test methods? In our example, we can have different implementation of edit profile method in green profile page and red profile page. We will have the same method but different implementation. Through data provider, TestNG data provider, we return to our test method the object. Actually, it returns us two massives of these objects. The third massive will contain two objects: green branding factory and green profile. It's just profile. Pay attention only that it's returning green branding factory, and the second massive is returning as the object of red branding factory. And returning to our test method, our can edit profile with valid values method except as parameter the object branding factory of type abstract branding factory. So how we can use it? From our branding factory object, we can invoke profile page, and it will return us red profile page or green profile page depending on which object will be sent from our data provider. So in this case, we can run one test, but for different implementation of edit profile methods in green profile page and red profile page. The class diagram of abstract factory. Our client uses abstract profile page. So as you saw before in our test method, our client in that case would be our test method. It accepts as parameter the object of type abstract profile page from data provider. Our test method, as I said, accept object of abstract profile page, but from data provider we put exact concrete classes red profile page and green profile page, which I'm mistaken. In data provider we put object of red branding factory and green branding factory, and from profile page methods in each concrete factory we can receive realization of concrete red profile page and green profile page. And that's that is all about abstract factory. So you can use it when you have the same functionality, but it differs differs under maybe under some environment of or because of different realization for different brandings. And difference between abstract factory and factory pattern. Factory pattern In factory patterns, the client expects an implementation of interface or abstract class, but it doesn't know exactly what concrete class the factory will return. In abstract factory, we have one more level of abstraction. So abstract factory, it's factory which contains inside it factories and other factories. For abstract factories, the client does not even know what factory is going to use. Firstly, it gets a factory and then it calls a factory method. So that's all about abstract factory pattern. And all the information you can read on you can find on the websites, and I would advise it for all of you read the great book by Katie Sierra, Eric Friedman. It's Head First Design Patterns. It's a book about developers patterns, but you can use it while writing QA automation framework. And for more fluent learning of Java, I would recommend to read Effective Java book. That's all. Let's see what questions we have. We have a question from Pavlo Rychlotsky. He asked if we need quickly implement some other tests and our small interactions are private, should we write a new big method in every such situation? Actually, if we required some small methods, we can provide public small methods. As in our case, login method consists of three actions: send keys for login field, password field, and clicking login button. But in case if we just need to send keys information to one field, it's possible to provide public method just to fill login field. So if you need in your test methods like small interactions with your page, you can provide small methods. I think I answered your questions. The next questions we have from Pavel Jestrzeb. He is asking, what are you recommending a framework for automation UI? Actually, if you are newly for QA automation and we are talking about Selenium WebDriver and its framework, I would recommend you first learn the Selenium WebDriver and its public API. And then there are some frameworks written around WebDriver, such as JBehave, Serenity frameworks. They are rather big frameworks, and they contain inside it already implemented page object pattern. So if you are experienced QA automation, I would recommend you don't use existed frameworks like Serenity or JBehave, and just run your own frameworks. On my project, we decided to just write our frameworks, and we just use TestNG, Selenium WebDriver, and Java as programming language. For us, it's better because already existed frameworks provide us a lot of public functionality, but if we want to change something tricky, so could be very hard. Just I would advise learn Selenium driver itself and its public IP, and you may just make a quick overview of wrapper frameworks around Selenium WebDriver, such as Serenity and JBehave. But JBehave frameworks is used more for BDD. It's behavior-driven development. When we have acceptance criteria, we need to write stories. It also contains a page object inside it, but as I said before, it can be difficult to change something and configure inside it. If you want a ready solution, you can use Serenity. Or we have one more framework. It's also wrapped around WebDriver. It's Selenium. It has some good ways to working with elements, verifying and assertion. Actually, I really like it, and it is more lightweight than Serenity. So if you just want framework for interaction with elements, weightings, verifying, assertion, you can just use Selenium. I think I hope I answered your questions. The next questions I have from Diego Jose Ortega Pelaez. Do you know how can be automated a Silverlight UI? Actually, I haven't had experience automation Silverlight UI, so I cannot advise you something useful. Sorry. But you can search in Google if you can automate it with if Selenium WebDriver can find elements inside Silverlight UI. If it's possible, I would recommend you use Selenium WebDriver. We have questions from Anonymous. If there are some approaches to run UI tests in scope of single database transaction, and in the end of test don't commit database transactions but revert it. For example, run tests which create user and after run transaction, and after a test is run, transaction is reverted and user isn't saved to database. Transaction is reverted. As I understood from your question, you're asking, so before each test method, you create you are creating a test user, and after method, you want to just revert your transaction. As we do in our framework, before our test method in precondition in setup, we just create a user account, but in after methods we just remove it from the database. But I think Spring framework and Hibernate provides such possibility to just revert your last transaction. So if I'm not mistaken, Hibernate provides such possibility. You should Google for it. But I would propose you just after test executed, remove the user from the database. You know its name, so you can just simply remove it. I have one more questions from Pavel Jestrizep. Does Selenium can be carried out test UI for mobile devices? If so, did you have any experience with this? In my practice, I only have experience writing tests for web applications, but Selenium, if I'm not mistaken, there is some open source realization of WebDriver. It's Android driver and driver for iPhone. So we have drivers for mobile devices, but I never have experience using the drivers. But for mobile devices, as I know, exist some very good frameworks for writing automation tests. It's, for example, Appium. So you can just search for frameworks that are particular specification on mobile devices. I think it will be better than using realization of Selenium WebDriver for its Android driver for mobile devices. So I would recommend you Appium. I read that it's a quite good framework for automation mobile devices. One more question is from Grzegorz Wroblewski. Do you build customized automation framework specific to every project? And do you have any good suggestions for sources of information on topic building automation framework? On writing your own frameworks to simplify writing tests. Actually, if your application is not very difficult, as I said before, in my cases, it had different implementation of the same functionality for different brandings, so we needed to make big and difficult framework using abstract pattern and so on. But if your application is quite easy, you can just use a simple way of page object patterns. It's when you have a page object basic class with page object basic class. It will contain methods similar for all page object components, and from that parent page object class all concrete page object and blocks will be extended. And for test classes you will have base test class in which you make all preconditions. If you are using testng or JUnit, you can make before method, before class, and after methods, and in that methods you can make all setup and tear down that are that is common for all test methods. And also in base test class you will be able to create instance of your WebDriver and use it in your page objects. So if your application is simple, your framework using page object can be the same with slight differences. Different will be maybe in some preconditions, helpers, creation users, working with database, but the model as page object work can be the same. Actually, you're asking, and do you have any good suggestion for sources of information on topic building and automation framework? So I would recommend you in all your projects, if you are writing tests using Selenium WebDriver, use page object pattern. You can find a lot of information about it in the internet. So it is simple, and you have a lot of benefits of using it. More questions? Someone asked about frameworks for automation mobile application in chat. It's written that we can use Selenium, Appium. Yes, we can use such frameworks. Thomas Kupis wrote in the chat that we could have locators stored in property file as well to make code more maintainable, but I like more when locators are stored in the page object component in to which that locators are related. I have one more question from Pavel Jestrzep. Have you had experience with BDD and SpecFlow? Is the short projects is the meaning of the use of those methodologies? I think you're asking if the project is short, can we use BDD and SpecFlow? So BDD is behavior-driven development. It is very good to use BDD frameworks such as JBehave. I used JBehave on my projects, but it is very useful to use it when someone is reading the stories in BDD language, such as given blah 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 preconditions, when it's steps interaction with browsers, and then step it's verifying an assertion step. So when business analytic is or someone from the customers or on your site is reading such stories in the Jerkin language using given when then, it is appropriate to use BDD on the short project. But if project is short and you do not have the person who will read such stories in the following Jerkin given when then format, so I would recommend you just use plain Selenium WebDriver and page object, because you have a double job like writing stories in Jerkin format and writing framework and tests itself. So if the project is short, if someone will write BDD stories for you, you can use JBehave or Cucumber. If not, just use plain Selenium.
Thank you so much, Mihailo, for your presentation.